Beyond the reach of nature, we are forging the impossible. It starts with a seed, a thin slice of carbon carrying the blueprint of eternity. Precision placement. This tiny sliver dictates the crystal's structure. The HPHT process, mimicking the crushing weight of the Earth's mantle. Raw carbon source. We use ultra-pure graphite as the starting material. 6 gigapascals of force. Extreme pressure for molecular transformation. Under pressure, graphite bonds are forced into a diamond matrix. Thermal chaos. Melting a metal catalyst to allow carbon migration. Alternatively, the CVD method. Growing gems from a rain of gas. A plasma storm. Methane molecules are ripped apart by microwaves, creating a void. The environment must be free of all impurities. Microwave activation, igniting the gas into a state of plasma. Carbon rain, free atoms falling onto the seed, stacking layer by layer. Thermal management, protecting the machine from its own internal sun. Slow perfection. It takes weeks of monitoring to grow a single carat. Precision control. A 1-degree shift can ruin the entire crystal. Regulating the fuel. The carbon flow must be perfectly consistent. The transition. From a flat sliver to a 3-dimensional gemstone. Atomic scrubbing. Hydrogen removes non-diamond carbon automatically. Scaled synthesis. Industrializing the creation of the world's rarest stone. Extraction. The stone emerges from its high-pressure metallic shell. Chemical cleaning. Stripping away the metals used in the growth process. The raw state, holding the molecular potential of ultimate brilliance. Laser surgery. Only light can cut the hardest material on Earth. Shaping the future, removing the skin to find the perfect heart. Digital planning. AI calculates the cut to maximize light return. Establishing the boundary, the first step in symmetrical geometry. Secure mounting. The stone must be held rigid for the polishing phase. Diamond cuts diamond. A disc spinning at 3,000 RPM. The abrasive mix, essential for achieving a mirror-like finish. Creating the window. The table allows light to enter the crystal. Mathematical precision, achieving a level of symmetry beyond human skill. The light trap, designing the internal mirrors of the gemstone. Human oversight, verification of the robotic work at 10 times zoom. Creating fire, breaking light into its spectral rainbow colors. 57 facets, the architecture of a perfect diamond. Final purification, removing every trace of polishing oils and dust. Clarity grading, Analyzing the stone for microscopic growth marks.
Type 2A purity. Proving the stone is chemically superior to natural gems.
The digital ID, an invisible serial number for full traceability.
Official authentication, validating the stone's quality for the global market. Secure handling, protecting the masterwork for its journey. The destination. Industrial science becomes a symbol of devotion. Withstanding the heat, specialized metals that don't melt at 1500 degrees.
Data-driven growth. Managing the atomic flow of carbon.
Extreme cooling, using liquid gas to maintain the system's vacuum.
Managing the carbon cycle. Ensuring only diamond crystals form.
Acoustic monitoring, listening to the sound of atoms stacking. Continuous energy. A 10-second power cut can ruin a month's growth.
Thermal absorption. Water cooling the heart of the forge. Controlled power. Managing the force of 60,000 atmospheres.
Recycled brilliance. Every grain of carbon is reused. Containing the sun. Materials that shield the press from melting.
Virtual forge. Predicting the future of the diamond in real time.
Heat-resistant containers for the carbon-metal mix.
Leak-proof engineering. Maintaining the purity of the vacuum. Witnessing the forge. Watching light become solid matter. Preparation. The raw fuel for our high-pressure synthesis. Testing the best with the best.
Zero dust. One speck of dirt can cause a crystal defect.
Robotic logistics. Handling wealth with mechanical precision. A source of energy. Powering the plasma storm. Atomic perfection. Seeing the tetrahedral bond of carbon.
Human validation of the digital growth plan.
Protecting the tool that cuts the world's hardest gem.
Checking for fluorescence. Ensuring the purest light return.
Ultimate integrity. No gas enters except what we allow. The library of eternity. Starting points for future gems. Identifying the origin. Proving the purity of the source. The silent finishing of the world's finest stones. Heavy metal for heavy pressure. Plotting the facets. The roadmap to brilliance.
Hydrophobic nature. Measuring the surface tension of the gem.
The heat sink of nature. Diamond conducts heat better than copper.
Instant authentication for the modern consumer.
Inspecting the growth rings of the man-made stone. Precision jewelry. Every prong is perfectly aligned.
Sustainable luxury. Created by the sun for the wearer. Micro-diamonds. The byproduct of industrial art. Secure transport to global luxury hubs.
Ultra-fast cutting. Minimizing heat during diamond dicing. Geometry at 0.0001 degrees of accuracy. Purging the system before the plasma ignites. The delicate touch of the final inspection. Quantifying beauty through optical data. Environmental stewardship in high-tech manufacturing. Sterile interaction with the growth seeds. Deep chemical etching for a clean crystal face.
Capturing the soul of the stone for the buyer.
Forging carbon with electromagnetic energy.
Harnessing the energy of the stars on Earth.
Sorting the spectrum. From decolorless to fancy blue.
Durability that reshapes other industries. Uniform growth, ensuring every side grows equally.
The blockchain of brilliance. Every stone is accounted for. Industrial applications. Diamond as the ultimate optical lens.
The dance of light, capturing every reflection.
The mark of the diamond forge. The Diamond Forge, where science masters the art of eternity. Apex Forge, perfection accelerated.